We actually haven't really talked about NDC since we got back a few weeks ago, but one of the interesting things that came out of it was that the idea of testing came up quite a bit. So we're all happy to talk about Kubernetes and how that plays into people's deployment strategies. And most of the answers we got were, yeah, look, we love the Kubernetes. We really want to use the Kubernetes, but we don't really have a plan. And, we're probably a couple of years away from doing it. But testing was a problem people were having today. And when they asked what our recommendation was, we didn't really have a solution for that. Which is a shame because actually Octopus is quite well positioned to handle the kind of end-to-end and integration testing that has to take place after an application has been deployed. And it seems quite natural that we should have some way or some suggestion on how to achieve this. But at this point, we don't really. The idea of feature branches has been thrown around in team integration for a little while. I don't think we actually have a really solid solution or use case or example that we can give people. So I thought it would be worthwhile to try and tackle this problem, see if it's possible, and try and find out, does Octopus support this? If so, how can it be done? And if not, where are the gaps? So I had a couple of goals in building up this example. Number one, I really wanted to minimize the amount of time you spend testing. End-to-end tests, once you get started, they can blow out to hours and hours if you're not careful. So one of the goals here was to have a solution that would scale up quite nicely as more tests were added. And as we'll see, one of the solutions here is to use Lambda with Chrome, because Chrome supports headless testing since probably early this year. I also wanted to find a way to make testing accessible to non-developers. Certainly everywhere I've worked where this kind of testing has taken hold, the people who tend to be most involved are like product owners or testing staff who are not necessarily developers themselves. So if the testing solution can encourage them to participate without requiring anyone to write actual code, that would be beneficial. Also wanted to look at using transient infrastructure. So that's building up what we needed for the test, running the test, and then shutting it all down. And so this works well with things like feature branches where you really don't need things hanging around for a long time. I also wanted to use tenants because that's kind of one of the big selling points of Octopus, is that we expose tenants as a first-class concept. And so I wanted to make use of them in tests as well. And then the last one was to use feature branches because everyone's asking for it, and we don't really have a solution at this point. So at a high level, the process that we go through looks something like this. So the first step here is to use a build server, and I've used Jenkins in this case, to build up a Docker image of the application that we want to test. And if I look at, so if I look at this, the Jenkins has what's called a Jenkins file, which is your build as code. And so this is the pipeline that we've got for the demo example. The first bit here builds up just a standalone Java application. That's actually this web application here, which is a sample ticket selling application. And then the next step is to put that into a Docker image and push that up to Docker Hub. So that was one of the questions that we got a fair bit, was does Octopus actually host Docker images? And so the answer is no. You always have to go through something like Docker Hub. So the next step is to have Jenkins start a deployment in Octopus. And so if we look back here, that's this stage here. And this is where some of the rough edges that Octopus has with this kind of dynamic testing starts to play out. Octopus is great when everything's configured up, like environments and targets and whatnot, and you can just kick things off. But if you're building up dynamic things, there's a lot of work that has to go on outside of Octopus itself to get to that point. And so as we can see here, I've created an environment. I've had to make up some new commands for the Octo CLI to associate targets and machines with the new environment, as well as associating tenants with the new environment. And then at that point, we can start creating releases and deploying releases. So the next step then is actually inside of Octopus, once it's been triggered by Jenkins, is to start building up some temporary infrastructure. And in this case, I've used Kubernetes to host the Docker containers that we built. And so as we can see here, Kubernetes consumes the image from Docker Hub once Octopus initiates the request for those resources to be built. And so that looks like, this is the project here that we're using to spin up the resources. So the first step is to create some dynamic targets. Now this is based a lot on the work that the Azure guys did with their PowerShell commands that build accounts and targets. So this was quite easy. This seemed fairly natural to do. And then from there, we can use that target to deploy two deployments in this case. The first one being a temporary database, and the other one being the web application itself. And so all of these resources are contained in a namespace. And so we're treating namespaces here in Kubernetes like some sort of like a resource container almost from Azure, just a place where everything can go in and everything can be destroyed in one go. So we understand what we've created and that we can clean it up quite easily later. So once the web app is up and running, the next step is to actually launch the test. And in this case, we've created an application that launches Chrome in a headless mode, and we're launching that from Lambda. So I can show you quickly what that looks like, not in headless mode, but what the test actually looks like locally. So here I've just spun up Chrome locally to run through the WebDriver test that would be run. And as you can see, it's fairly simple, but it's quite quick. And the test that actually is being run is WebDriver being driven by Cucumber. And Cucumber then interprets what's called a feature file. And this language here is called Gherkin. And so you can see here, these are the individual steps that make up the test. And so this addresses the goal of making testing accessible to non-developers. Because as you can see, these steps are pretty easy to read. Like if you read that from top to bottom, you could understand what was going on. And it actually doesn't take much training to write these tests either. And it's all just plain text, so you don't need any special tooling to get involved. We have a bit of a disconnect here though, because once we spin things up in Lambda, it's all asynchronous. Lambda won't call back to Octopus with status updates. So what we needed was some way to monitor the status of those tests as they're being run in Lambda to wait for when they'd finished or when they'd failed. And so one of the easiest ways to do this was to have the Lambda write logs to CloudWatch. So CloudWatch, for those who aren't familiar, is like a logging system that's provided by AWS. It's kind of provided out of the box. You don't really need to set anything up. And actually Lambdas, as they write anything to the console, those messages are put into CloudWatch for you automatically. And so the good thing about CloudWatch is it's highly available, it's quite performant, and it has good tooling that allows you to query it quite easily. So we take advantage of that to through the use of like a correlation ID. We say start a test with this ID and then just watch CloudWatch for any status updates that happen. And also the Lambda will upload the result of any test to S3. And so what Octopus is doing here is just querying CloudWatch over and over, waiting for the test to finish, and then downloading the results. And so we can see that through the output. Yeah. So this is where we've kicked off the Lambda, and this is where we've polled and waited for the results. And as the files have become available, we've downloaded them and attached them as artifacts. And so the good thing about Lambda is it scales almost infinitely, right? At this point, we can just initiate a test and we can just let our AWS handle all the resources and all the scaling for us. And we don't have to think too much about it. So if we had 100 tests that all took 5 minutes, assuming the app that we are testing can handle that kind of load, we could just spin up 100 Lambdas and have them all run in parallel. So the scale up is quite natural and quite easy to achieve. So once the testing has completed, Octopus will then tear down the infrastructure that it created. And because this is all in a namespace, the teardown is actually not much more than delete namespace, which we can see here. So we delete a namespace, and everything we created is cleaned up, and we're good to go. We also remove the target that we created at the beginning of the test to make sure that's clean as well. And then at that point, because Jenkins has been polling Octopus, the results are then made available back in Jenkins. So if we look at, I don't know if you guys have seen this, actually, Jenkins kind of has two modes these days of user interface. This is the classic interface. This is where you do all your management and all your input. This is called Blue Ocean. It's like a dashboard. And I think the idea is that if you're using pipelines, all your configuration is pretty much in code anyway. And so you get this pretty dashboard that you can't enter anything into, but lets you query the results, and is quite a great deal nicer than the old UI used to be. And so this is what you see from Jenkins. We started it, we built the Docker image, we did the UI testing, and then it all finished off, and we get a green result back in our build system. So this process highlighted some of the value that Octopus could provide. Multi-tenants and variables was, I think, a big one. So if we look here, I ended up setting up the variables. So I used two tenants to kind of represent maybe two different kinds of users who would be using our application. Maybe one is doing buying rock concert tickets, the other is doing more theater stuff. And the benefit of using tenants and having the variables set up in Octopus is that you get a nice view of the data set, I guess, that make up your test. I haven't really seen any other tool present the various inputs that might go into a test in a particularly nice way. But using the variable and the variable preview here, sorry, I should unsource, it's quite easy to visualize what a test data set is. So in this case, I can see that for the event, hosted one is doing rock concert, whereas hosted two for a particular feature branch is doing a theater show. I mean, the only tool that I've seen that really comes close to presenting this kind of information is Excel. And I don't think we want to promote the idea of using Excel as a data source. And so the other thing is obviously that these variables are defined quite richly these days. So these could be checkboxes or drop downs or single line text, and we get defaults and other processing. So the way Octopus manages variables, I think, is quite a strength in this case. It's very easy to define the kind of variables that need to go in, to review what variables have been defined, and to give people the opportunity to enter their own variables through a dedicated form. Docker images as deployment resources. I don't really think you get this through a CI server. So in our case, one of the resources that we needed to deploy was MySQL, and a very specific version of MySQL. We couldn't actually use version 8 because it introduced some new feature that wasn't compatible with this application we were testing. And this is very much a deploy time concern. Like, we're not consuming MySQL as part of the build or anything like that. And Octopus makes it very easy to consume these resources, these deployment resources, and limit their versions and deal with versioning in a very natural way. So I thought that was quite a benefit too. The dashboard overview has a lot of potential. So as you can see, these are the branches. These are the Git branches, and they've been modeled as environments here, and I'll go into why that is later. But we can see, 1 out of 2 has run the test at this particular version. This one's failed, and this one also 1 out of 2. So I think the ability to just have an overview like this is quite powerful. And I think this will get more powerful actually with something like spaces, because you could potentially have a testing space, for example, that would really focus in on these kind of tests and their results. Workers too, like, we haven't used workers here, but if you wanted to do all this locally without going out to the cloud, I think workers provides a lot of strategies there as well. Certainly for testing, maybe you want to test from IE, you need a Windows worker. You want to test from something else, you can use a Linux worker. There's a lot of flexibility around that. So I think that's what went right. So what didn't go so well? Implementing this required a deep understanding of every part of the process. I certainly wouldn't expect anyone else, outside of an Octopus development team, to piece all of this together. And actually they couldn't do it today anyway, because there was some customizations that had to be made to OctoXE to make all this work. It's also all scripting. There's not really, I can't just drop in a step and fill in some fields to get this to work. I have to know how to script it and the order to script it in. So all the feature branches had to be modeled as environments because that was the only way to isolate them. So the only way really to isolate a target, when a target represents where you're deploying a feature branch to, is either through a role or an environment. And roles aren't really dynamic. Like, I can't go back to my project and if I go back here, I need to know what the role is up front. Like, this bit here isn't really all that dynamic. And so the only way to have machines or targets isolated from each other was to have them in different environments. I thought perhaps maybe the deploy to flag from OctoXE would work, but that needs the targets to exist beforehand. And in this case, we're actually creating them as part of the deployment. And so the follow-on from that is that there's a lot of work, as we saw before, to create the environment where a test can be run outside of Octopus. And so in this case, we need to create the environment, we need to associate tenants, we need to associate machines, and all of that needs to be done through a tool like OctoXE. And that actually can't be done today because it just doesn't have the steps or the options or commands that we need to do that. It's fairly easy to add, but it's just not there. It's just not something we can give people today without merging in some new changes. And also the flip side of that is you could script a lot of this up using the client yourself if you wanted to, but that's not really accessible from Linux. I mean, it's great from PowerShell, and I guess you could install PowerShell on Linux, but if you didn't want to use PowerShell on Linux, then you don't have a lot of options, really. You make raw HTTP calls, or compile up a C# application or something like that. It gets a bit messy from a Linux host. So that's where I think this is where we kind of fall down a little bit. But there's a lot we can do here that can be improved, and some quite easy wins actually if we just flesh out OctoXE a little bit more. Yeah, so overall, I think it was a worthwhile exercise to walk through this and actually try and use Octopus as a test coordinator. I think with a little bit of work, this is something we can add a lot of value to. We're not quite there yet. There is some work to be done, but it is a problem that almost everyone would be facing today anyway. Like, this is not a hypothetical issue, and this is something people are asking for. So I think pushing some of these changes through would be quite worthwhile. And that is my presentation.